Okay, good morning, students. Now we will discuss number 6. A laser ray with wavelength 900 nanometer travel from air to glass prism with refractive index of 1.5. Yeah? The question is what is the wavelength when it enters a glass prism with refractive index of 1.5. And the frequency did not change. Okay, let us see the whole question. Yeah? A laser ray with wavelength 900 nanometer travel from air to a glass prism. What is the wavelength when it enters a glass prism with a refractive index of 1.5 and the frequency did not change? Yeah, once again, the frequency did not change. Okay, we start from the known. Yeah? We know the wavelength of the laser ray from air equals to 900 nanometer. So we can say that is lambda 0, because this is the wavelength of the laser ray in the air. So lambda 0 is a suitable symbol. Lambda means the wavelength and 0 means the air. It means this is the condition of the wavelength of the laser ray in the air, 900 nanometer. Okay? As we know from the theory that speed of light changes when it enters a new medium, and also the wavelength, it will also change. And that's why we denote the wavelength of the laser ray in the air is lambda 0. It equals to 900 nanometer according to the question here. Okay, so the wavelength of the laser ray equals to 900 nanometer when it travels in the air. Okay, now we go to the next. You must know that the refractive index of the prism 1.5. You can see it from the question. Yeah, see, a refractive index of the glass prism 1.5. Yeah. Okay, now we go to the next step. So we can write down n prism, yeah, and plus 1.5. So now what is being wanted? We will see in the question for one more time. What is the wavelength when it enters a glass prism? That is what is being wanted. Yeah? What is the wavelength when it enters a glass prism? Okay. So what is being wanted? We can write down wanted here. And oh sorry, the wavelength. Yeah? Okay, the wavelength. Okay, what is the wavelength when it enters a glass prism? So what is being wanted is uh, lambda in the glass prism. I hope you are still clear until this step. Now we will go to the answer. You have to remember that V equals to lambda times f. V is the speed of the wave, lambda is the wavelength, and f is the frequency of the wave. Okay, now we will go to the next step. I hope you still remember about the formula from the previous number, yeah? I mean from number 4. That from number 4 and 5, we know n equals to C divided by V. Okay, and now we can write down the formula like this, yeah? N equals to C divided by V. And then we know C is the speed of the light in vacuum, and V is the speed of the light in medium. Okay, and according to our discussion before, yeah, you have to remember that V equals to lambda times F. That's why we will change the V becomes lambda times F also for the C. C is also the speed of light, but in vacuum, and V is the speed of light in a medium. And we will use the formula of V equals to lambda times F in this formula. Okay, let us see. Lambda 0, because in the air, this is the speed in the air, times F per lambda times F. We know from the question that the frequency did not change. Here, the frequency did not change. Okay, so we can scratch the frequency because they are constant. So they are the same. Then we can delete the frequency. And we get lambda 0 divided by lambda. Remember that lambda 0 means the wavelength in the area. Let me give you a clue here. The wavelength in the air, not in the glass prism. Okay, so lambda 0, 900 nanometer, is the wavelength in the air. What we will calculate is lambda in the glass prism. Okay, so this is actually our problem. We know the wavelength in the air. We know the refractive index of the glass, 1.5. And what is being wanted is lambda in the glass prism. As I told you before in the beginning of the question, that speed of light change when it enters a new medium, and the wavelength of the wave also change because the speed change. And now we want to calculate the wavelength of the laser ray in the glass vision. Okay. Okay, we got that n equals to, let me write down the formula that we will use. N equals to lambda 0 divided by lambda. So it means 1.5 equals to lambda 0. Just remember lambda 0 from the known is 900 meter. Here, 900 meter. The lambda 0. Divided by lambda equals, so we can calculate the lambda now. So the lambda equals to 900 divided by 1.5. Lambda equals to 600 nanometer, because the unit is nanometer. Okay, this is the final answer. I hope you understood the details of calculation. What you have to remember is about this one. Yeah? Please remember this one. That V equals to lambda times F and N equals to C divided by V. Okay, this is from me. I hope you understood the detail of calculation, and you have to use your prior knowledge about V equals to lambda times F and then N equals to C divided by V. Okay, thank you for your attention. See you in the next